All right, on to task number 4. So let's see what we got here. All right, so we have a very familiar data set. This should look very familiar. For this task, find the average population for towns in each county near us. Then, find the same for the size in square miles. The first one has been done for you for reference because average if functions are a little tricky. Yeah, they are. After you figure out those averages, create functions that give the smallest and largest town sizes and populations. There are formulas that find the maximum and minimum value among a range. Finally, find the average and median populations and land sizes. Be sure to reflect upon if the average or the median is a more accurate result and why. So we got a lot of things to figure out in this data set. What do we got here? All right, so we have the average population for a town in Orange County is 15,770 and change. Okay, let's look at this formula and see exactly how it was built. Okay, equals average if, okay, that's our new formula. B2 through B934, that's this column here. That's talking about all the counties. Then we're talking about the specific county, that's Orange County. And then we have C2 through C934. So it looks like we have a 3-part function here. This first one gives us the range that we're going to make our rule for. This next part is our rule. And then this last part is the column or the range that we want to find the average of. Okay, so that's 3 different things that are going on here. But when we press enter, it gives us the average town size for any town in Orange County. All right, so now let's try repeating this idea for Sullivan County. All right, we're going to remove the question mark. I'm going to say equals average if parentheses. The first thing is we need to make our rule or our range that we're going to look for, or basically what's the rule or the situation. So it's going to be B2 through B934, comma, within that column, what am I looking for? The word Sullivan, comma, and then I need to actually find the range of items that I want to find the average of. So that's C934. I forgot to, there we go. C2 colon C934. Made a little typo there, but it's good to recognize those once in a while. So now this is finding the average if the Sullivan values within that range B2 through B934, and then we're finding the average from this final range at the end. And when I press enter, we get 5,169. All right. Now there is a little shortcut that we can do here, right? Because these are finding the same 2 columns for the qualifier column and the average column. So if I copy it all, and I go into this next one, all I have to do is change one word, right? I can change this to Duchess. And when I press enter, we have it found out. All right, so that's pretty neat that we can just kind of copy and paste our formula in. Let's do one for the average size of square miles, and then we can go from there. All right, so this one is going to be equals average if parentheses. What do we want to look at? Well, first we want to look at these counties, right, through B934. That's the items that we're going to look for to make our rule, comma. Then we're going to put in our rule, which is orange. That's the word that we're looking for in that list of counties, comma, and this time it's D2 through D934, because that's the column that we want to find the size in square miles. When I press enter, we have 38 square miles is the average size for a town in Orange County. So that first part seems pretty straightforward, so that's something we can build through. Let's take a look at the next piece. What is the smallest amount of land granted to a town? I only need to show us one of these because I think this is a pretty easy approach. Smallest amount of land? That sounds like the minimum. Equals min parentheses, and we're going to search D2 through D934. And that's it. right? That's the smallest amount of land, so it has to be the minimum. This next one would be the maximum of that range. And then you should be able to figure out the smallest population and the largest population, because again, they are min and max values. All right, let's take a look at these next ones. The average population, you should be able to figure that out. We've seen those before. Median population as well. So let's do one of these. Equals average, parentheses. If we're dealing with population, we're using column C, so that's C2 through C934. And I press enter. And that's pretty much it on there, right? That's all that we really needed for our solution. Median population, well, I'm going to get super lazy. I'm going to copy this formula, this function, and I'm just going to change the word average to median. And there we go. We have the median population. So what's going on here? If the average population is 9,631 and the median population is only 2,906, a lot of the times when I look at these things, I would say there's probably a few very, very large population towns that are raising up the average. But remember, with the median, you arrange all the town populations from the smallest to the largest. And then you find the middlemost point, and that's the number that's the median. When we get into our probability and statistics chapter, we're going to be looking at these two and trying to see what type of insights or information we can take from these items. So now we need to type in an answer here. How did the average population versus median population compare? Average was larger, median was smaller, probably because there are some towns with huge populations. That's all we really need to kind of get from this for now. This is kind of like a teaser for future content that we'll be looking at. I'm not looking for you to have the perfect answer, but I am looking for you to try to figure out some information. And if you have some guesses, I'm more than happy to respond and look at these and say like, well, you know what? That's actually an interesting question. Maybe we can investigate further. Or maybe we do have an answer of exactly why some towns are massive while other towns are a lot smaller. In a future assignment, we're actually going to be using these figures that we're getting again, and we're going to be looking at the population or the number of people per square mile. So for example, we have 15,000 people, 38 square miles. You know, there's a density or how tightly packed people are together on the land, and we can figure out which of these counties have the closest living quarters or they're more spread out. And I would say the more open or wide that a county is, probably the fewer people that will live there. So it's definitely something worth considering looking into, and we'll see exactly where this data takes us throughout this spreadsheet journey. But that's what we're looking at for tasks 3 and 4. The next thing we need to tackle are tasks 5 and 6.